So in this video, I'm going to continue on with this question that Bala asks in chapter 6, which is, what made the Renaissance in Europe? So I did some setup in the other video for this week, so if you haven't seen that yet, watch that one first. But I'd like to dig into one half of the story that he tells, which is that Europe in this period during the Renaissance is doing a massive sort of importation of knowledge from two enormous political organizations that are on their borders, one of which is the Islamic Caliphates, and the other of which is the Mongolian Empire. So in this video, I'm going to go through kind of the history of the knowledge that gets fed into the Islamic Caliphates, which then get fed into Europe during the Renaissance. Next week, I'll take up the story on the other side, the Mongolian empires, where knowledge from India and China and lots of other areas were collected and synthesized as well. Okay, so let's dig into the story of the sort of learning in the Islamic Caliphates, which goes back, you can trace the story really far back. Here's the Islamic Caliphates at their kind of peak in terms of geographic extension. As you can see, they go as far west as Spain, as far east as Afghanistan, really massive areas. And if you want to know about the kind of science and technology that's present in these areas, you have to go way, way back. So you can go as far back as ancient Mesopotamia, where we started in this course. So the kind of knowledge of astronomy and mathematics and other sciences developed in ancient Mesopotamia gets spread around the area by people like the Neo-Assyrians. It gets combined with ancient Egypt. This is one of the cultures that I wish I'd gotten to when we're talking about ancient astronomy, because ancient Egypt is also very sophisticated for its time in terms of astronomy and mathematics particularly. So we can see that, for example, in these massive construction projects, like most famously the pyramids at Giza, where the whole building is aligned very, very precisely with important features in the sky. These features, like what the North Star was, have actually shifted over the millennia since this was built. But if we run time backwards with our astronomical models, we can see these buildings were built with sort of like very important celestial phenomena in mind. Okay, so there's this very, very long tradition of mathematics, astronomy, and that kind of thing, medicine as well, coming out of Egypt. And all of those things fit into, or filter into, the ancient Greek world. So the ancient Greek world, we're usually, by ancient Greece, you usually mean something like 500 BCE to 300 BCE in that period. And the ancient Greeks are travelers, they're merchants. So ancient Greece was a pretty prosperous society. They're exporting lots and lots of olive oil and wine, doing pretty well at it. Being a trading culture and having access to the Mediterranean means they're traveling around a lot. And the knowledge that was generated in ancient Mesopotamia, ancient Egypt, and the surrounding areas is being kind of collected and analyzed and worked on by the ancient Greeks. So this is where the standard story of the Renaissance usually starts. So they start with the genius of the ancient Greeks. They were super smart people, there's no question. They were very intelligent, very curious, but a lot of their knowledge is actually inherited from these previous cultures. Okay, so let's go from ancient Greece, talk a little bit about what they were on about. So I'll just give you a couple of examples of the kind of things that were going on in ancient Greece at the time. So here's Empedocles. So ancient Greece, science and philosophy and sometimes religion are still kind of all mixed up together in a fun stew. So Empedocles claimed to be a daemon, a kind of spiritual creature, banished by the gods for, quote, 3 times countless years to the lower orders of the cosmos, that's us, for the sin of having eaten meat. So Empedocles thought that he had achieved the most perfect human form in his lifetime and was therefore going to be reborn in a higher celestial plane as an immortal. Okay, so not what you would call the modern scientific attitude. However, he does set up a kind of theory of matter that gets passed around the ancient world for thousands of years after this. So you can see the impact of his theory of matter on late medieval to Renaissance to early modern medicine in Europe. So this is his model of matter: earth, air, water, and fire, a combination of the properties of being hot, dry, wet, and cold. And the idea was that nothing is created or destroyed. Matter is just transmuted between these different properties. He believed that there are two fundamental principles that drive the change in matter between these ways of being: love and strife. And there's this ultra long cosmic process whereby love and strife change places. So when love dominates, everything's mixed together in one big perfect sphere. The perfection of spheres is going to be a big theme in ancient Greek astronomy, astrology. It'll come back a bunch of times. But when strife increases, when things become less perfect, things start getting separated out and mixed up and generally messed up. So Empedocles, he's got a theory of matter. He's got a theory of the development of the cosmos. Not super clear that what he's doing is science in the normal sense of science that we think today. It's a kind of mixture of spirituality and speculation about the overall structure of the cosmos. A little more sciencey, perhaps, is Aristotle. So Aristotle's one of the most famous figures in the history of philosophy and the history of science. And his work is a kind of synthesis of a bunch of ideas that were around at the time, combined with his own personal contributions. He made contributions to just about every field of study that you can think of, which is an annoying thing for somebody to have done. I'm here trying to scratch out this one tiny contribution to one tiny field. This guy did it all. Astronomy, biology, logic, rhetoric, like anything you can think of, Aristotle's got a book on it. And the pattern of studying the natural world that Aristotle sets influences the ancient Greek world very profoundly. It influences what we'll talk about in a minute, which is the Hellenic world. It comes to influence the Islamic world, and then through the Islamic world comes to influence Europe. So this guy's influence sticks around for thousands of years. Just to give you a very brief overview of Aristotelian physics and cosmology, if you've never seen this before. So Aristotle more or less accepts the view that I just described of Empedocles, the idea that there are four elements, actually five, but the fifth one doesn't typically appear down here in Earth. So the four elements: earth, air, water, fire. Fifth element called quintessence, which is what the stars are made of. So our earthly world is a mixture. It's all mixed up of the four elements. And because it's so mixed up, the pure essence of things doesn't really come through, which means that mathematics, which is a sort of pure form of things, only sort of applies to the Earth. So Aristotle's physics contains no mathematics. Math, in Aristotle's view, really only cleanly applies to the heavens, where things are unmixed and pure. So he's got this picture of what moves things, how things change over time down in our earthly realm, which is in the center. And he thinks that it's the character of the four elements that makes everything go where it goes. So fire has the kind of goal to move upwards to its proper realm, which is up above the air. So every time you light a fire, it seems to go up. Why is that? Because fire's goal, its telos, he says, is to rise above the air. Why do rocks fall down? Well, they're made of earth, and Earth's proper place in the universe is at the center, in the middle. So why do rocks fall? You throw a rock up, it comes down every time. It's a very regular observation. Aristotle's explanation for this is that the rock's goal, its purpose, or its proper place is in the middle of the universe. So, okay, so there's a lot more to it, but there's a rough picture of Aristotelian physics, which is hugely influential, basically until the Renaissance, all over the Western and Islamic world, although Aristotle's contributions are largely forgotten in Europe for most of what are sometimes called the Dark Ages, or the period after the Roman Empire falls, the Western Roman Empire falls, until the Renaissance, more or less. Okay. So you may or may not have been blown away by those amazing scientific insights. Ancient Greece is probably more famous for their contributions in things like logic and philosophy and their overall attitude towards knowledge, which is free inquiry and debate. Maybe the more impressive technical contributions come from what's called Alexandrian, or what Bala calls Hellenistic science. So here's a picture of Alexander the Great. Alexander the Great was tutored by Aristotle. He was a student of Aristotle, but he was also the son of Philip of Macedon, and Philip of Macedon was a very canny military ruler and took over a lot of land. Not quite as much as Alexander does, though. So the Hellenistic period is typically understood to be the period after Alexander's death. He died quite young after having taken over quite a large fraction of the entire planet. So here are Alexander's conquests. As you can see, they go from Macedonia to like India. Like, he takes over a really large portion of the world. Now, he dies young, and his empire falls. He's not as good at keeping the empire together as he was at taking it over. His empire falls apart into 3 separate empires shortly after his death. But the pattern he sets up in this overall empire is very similar to the one that we talked about with the Achaemenids, where people are mostly allowed to keep their own culture so long as they pay taxes. And the kind of unification of this massive area definitely increases after Alexander's conquests. So this is the Hellenistic world, the world in which the influence of Alexander's conquest holds sway. Alexander is a pupil of Aristotle. He thinks that the ancient Greek learning is very important. So ancient Greek ideas get spread far and wide in this set of empires. Okay, so, and Alexander has the same kind of idea that good old Ashurbanipal had. There's an old Persian tradition that says that Alexander was actually inspired to create the famous Library of Alexandria after having seen the Library of Ashurbanipal that I mentioned previously. So it's not altogether true or certain that that's true. It's a unconfirmed rumor, but certainly there's something true about it, which is that he decided that what he was going to do was similar to what good old Ashurbanipal did, which was collect learning from all over his empire and centralize it and have people synthesize it. So take ideas from this huge area of land, bring it together, have the best of it picked out, and try to clearly try to make the most of it. So he funded this really massive project of, bring me all your smartest ideas. We're going to put it all in one building. And then I'm going to fund a kind of class of scholars and scribes to study it and build on it. And the results of this project were really impressive. Here's where the sort of ancient Western natural science gets super impressive. For example, Euclidean geometry. So Euclid was a guy who lived around the time of the Library of Alexandria. He worked there, and his textbook gets used for thousands of years. So he formalizes geometry in a way that it hadn't been formalized before. He axiomatized it, if you know what that is. So this is a textbook from 1600 years later he's still in use. So Euclid's geometry is a product of this time and place. Another person who kind of worked and lived around this area, Eratosthenes. So he's a beautiful example of kind of the multicultural character of Hellenistic science. So he's born in Libya, he's studied in Athens, and then he works in Alexandria. And he was able to do, so he's a mathematician and an astronomer. He was able to produce an estimate of the size of the Earth. So what he does is, in very distant cities, he measures the length of the shadow at the same time. So what you need here is a good estimate of the distance between the two cities. You need a good way of keeping time so that you can say when you're making your measurements, so you can say it's at the same time, and then some pretty good math. And unfortunately, the units he was using are a little obscure to us. So he's measuring this in stades, which is like the length of a stadium, which is we don't know exactly how far he meant. But as far as we can tell, his estimate for the size of the Earth was something like 45,000 kilometers, which is not bad compared to the modern estimate of something like 40,000 kilometers. So Eratosthenes in, 2,200 years ago, something like that, was able to come up with a pretty good estimate for the size of the Earth. And by the way, people back then knew that the Earth was round. Nobody thought the Earth was flat at this point. Okay, so another really impressive sort of product of the Alexandrian project of bringing a whole bunch of knowledge together from Egypt, from Mesopotamia, from India, from the ancient Greek world, bringing it all together, centralizing it, spending state money to fund people to translate and research this stuff and to do something new with it. And what you get are people like Eratosthenes. Okay, so then a bunch of stuff happened. That's my way of saying let's skip ahead by 800 years. Specifically, a bunch of stuff happened like the rise and fall of the Roman Empire. So the area that Alexander conquered is largely captured by other people, a lot of it by the ancient Romans. The ancient Romans had a roughly multicultural state as well. But let's skip over that to the main topic, the one that sort of feeds directly into the European Renaissance, which are the Islamic Caliphates. Okay, so 622 CE is the beginning of the Islamic calendar, and it's during the time of the Prophet Muhammad. So between 622 and 750, all of the area except the bits in purple, so the bits in purple are still non-Islamic, but all of the rest of that gets conquered by various sort of like people in the tradition of Muhammad, either Muhammad or his direct descendants. So that's a huge area to conquer in a very small amount of time, once again. And once again, they've got a pretty clever strategy for getting people to accept their rule. So once again, they're not, I mean, if you calling this an Islamic Caliphate might make you think that everybody in there is forced to convert to Islam, but they are not. So a lot of these areas are going to be minority Muslim for a long time. And in fact, there was a kind of financial incentive for the people running these far-flung parts of the empire to not convert people to Islam because Muslims were taxed a bit lower than non-Muslims. So if you leave people with their Christianity or Judaism or Buddhism or Zoroastrianism, you get a bit more tax money out of them. So they're certainly not imposing Islam on these people. They are imposing their political rule, but not the cultural stuff. So this caliphate at its peak is enormously culturally diverse. There's lots of people of different cultures and faiths all living together under the same kind of political organization. And this is the classic problem. How do you unify these people? And specifically, how do you legitimize yourself in their eyes? How do you create the picture of yourself as the legitimate rulers? And they used a good old-fashioned technique. I mean, this is something that we saw with a bunch of the previous empires. So in this version, it's called the translation movement. So the translation movement was started around 750 CE. This is at the beginning of what's called the Abbasid Caliphates. So the Abbasid Caliphs decide that they need to kind of demonstrate their cultural legitimacy. And they decide to make Arabic, the language in which the Quran is written, into a multicultural language of learning. Right? So in the old Roman Empire, Latin was like, if you wanted to be learned, you learned Greek or Latin. It's a language of learning. they decided that they were going to make Arabic into a language of learning. So what they did was spend huge amounts of public, like their resources as rulers, to collect texts from all over their newly conquered, or newly in the last couple hundred years, all over their territories, bring them together, centralize them, and translate them into Arabic. So after the fall of the Western Roman Empire, for example, the works of Aristotle are largely forgotten in Europe. Like the literacy rate is low enough, and the challenges of, writing this stuff, copying this stuff all out by hand, the interest in learning is low enough, they just lose all of Aristotle. So Aristotle's this prolific philosopher and scientist, just lost to Europe. They keep a little bit of Plato, frankly, not much Plato, but that's the best they can do. But they were preserved in the Eastern Roman Empire, in the Eastern Roman Empire, and in the Islamic world. So this translation work, where they're bringing from not just sort of the Eastern Roman Empire, but all over the kingdom, which stretches, again, from Spain to Afghanistan, they're bringing together all of this knowledge, and they're synthesizing it in places like Baghdad's House of Wisdom. So they institute these houses of wisdom, which bear an uncanny resemblance to the universities that are going to be founded in Europe 300 years later. They're kind of the same deal. So the caliphs fund a whole class of scribes and scholars and translators. And you could do very well as one of these people. So not everybody got paid this well, but one of the top translators for one of these caliphs was paid, so he would bring a new book into the houses of wisdom and translate it. He would be paid that book's weight in gold. It's not bad, right? So they're pouring money into this project of collecting, synthesizing, and translating knowledge from all over the caliphate. Okay, so and what this produces is a really vibrant intellectual culture. They're not just collecting this knowledge, they're building off of it. And that's the point that Bala wants to make in chapter 6. So there's this kind of old story there's an old story in Europe motivated by the idea that European culture is the only one that can do science, that the Islamic world just kind of held on to this knowledge for a long time, and then Europe got it back after the Crusades. Bala is going to resist this. He's going to point out that there was a very vibrant intellectual culture going on in these houses of wisdom, not just in Baghdad, kind of all over the caliphate. Okay, so Ibn Hayyan, he's a nice example. He wrote on a huge variety of topics, including cosmology, medicine, philosophy, and especially alchemy. I'm not sure if he actually dressed like a wizard or he's just represented that way here. Unclear. No, it doesn't matter. But one of the most impressive ones to my mind is, we'll come back to this when we talk about alchemy, he discovered aqua regia. And aqua regia is a mixture in what today we would call nitric acid and hydrochloric acid, and you can use it to dissolve gold. And that's a big breakthrough. So if you're in the alchemy business, you're very interested in maybe producing gold from other stuff. So if you recall the theory of matter produced by the ancient Greeks, everything is basically the same stuff going through different kind of transformations. So if you believe that, well, then that gold is just one form of matter. All matter's basically the same in just different forms. That means you should be able to turn non-gold into gold somehow. So that's an appealing thought if your currency is based on gold. So the idea that you could dissolve gold seems like a really important step in that direction. So this guy comes up with aqua regia, the mixture of nitric acid and hydrochloric acid that lets you dissolve gold. Very interesting practical advances in alchemy. And this is just one example. There's a whole bunch of them. Here's Ibn al-Haytham. All these guys are given European sounding names, but I'll just give you the Arabic ones. So He's, again, a kind of philosopher slash scientist. And I just want to read you a quote from this guy to give you a taste of the kind of intellectual atmosphere that's brewing at this time. So he says, quote, "The duty of the man who investigates the writing of scientists, if learning the truth is his goal, is to make himself an enemy of all that he reads and attack it from every side. He should also suspect himself as he performs his critical examination of it, so that he may avoid falling either into prejudice or leniency." So this is not the dogmatic attitude that you might associate with religious thinkers. And all these people are religious in one way or another, but they're developing this. I mean, if ancient Greece is famous for having this attitude of free inquiry, free expression, and really trying to get to the heart of things without being dogmatic, you can see that exact same attitude in the Islamic world at this time. Okay, one more. Let's talk a little bit about the theory of optics. So this is a really nice example of how these scholars and scientists and philosophers weren't just sort of passively receiving knowledge from all over the world. They were actually building on it. So theories of how your eyeballs work. So, okay, how do your eyeballs work? And they're from the ancient world. The ancient Greek world, there was a bunch of different theories. So here's at least 4 different theories of what's going on with vision. How does that work? So Aristotelians thought that there's a kind of, there's air, and that vision is a kind of alteration of that medium by external objects, some kind of change in the air between you and the object. It's a theory where something is going into the eye. The Epicureans, another kind of ancient Greek school of philosophy, actually thought that vision works by a very thin layer of whatever you're looking at coming off it and going into your eye. So don't look at your stuff too much, or it'll get thinner and thinner over time, I guess. Okay, so those were intromission theories, where something goes into your eye. There was also extramission theories, where stuff comes out of your eyes. So the Euclideans, you remember Euclidean geometry? He's got a school around him. So the Euclideans think, in good geometric fashion, that there's a kind of visual cone coming out of your eye. So in a cone shape, some kind of thing emanates from your eye, and when it touches something, then you see it. And the Galenic, so Galen is a famous doctor from ancient Greece, or the Hellenic world, sorry. And he thinks that a visual fire is coming out of your eyes. So the theory here is stuff is shooting out of your eyes, and that's what vision is. When it goes and touches something, that's when you see it. Okay, so four theories of vision, two of which have stuff going into your eye, and 2 of which have stuff going out of your eye. Now, these get synthesized. Ibn al-Haytham takes the best parts of these ideas and puts them together into something very similar to our modern idea of how vision works. So he takes from the Euclideans, if you remember, they've got this visual cone idea, but they think something's coming out of the eye. He combines that cone notion with the intromission theories, which say something is going into your eye. So through developments in optics and understanding how light is moved through space and changed by going through stuff, he was able to come up with the idea that, light is bouncing off things in an uncoordinated way. So light hits something and bounces off it in all directions, but then when it hits your eye, it does so in the shape of what you're seeing through the lenses of your eyes is a visual cone that becomes a coherent image. Now, he was a little bit off in that he didn't realize that it was the retina in the back of the eye that was doing the seeing. He thought it was the lens. But this is compared to the 4 that I just told you, I hope you agree, this is a big step forward in getting to the modern idea of how vision actually works. So a nice example of the scholars and philosophers and scientists of this time, not just taking what's there and sitting on it and being like, we're smart now because we took a bunch of ideas. They're actually moving it forward in really important and substantial ways that get us closer and closer to our modern picture of the world. Okay. And this advance on optics. So based on al-Haytham's geometric treatment of vision, you can actually build geometric models of how to do, for example, perspective drawing. So remember in the last video, I started it off with this extremely flat two-dimensional image that was before the Renaissance, and then a much more, a painting with much more depth and perspective in it. So the shift from 2D paintings to perspective-based paintings is actually based on the insights developed by al-Haytham's optics into how to do how vision works. So that very impressive shift is based on the synthesis produced by people like al-Haytham in optics. So cool. Also of note, of course, is this stuff about Arabic, what you might call Hindu Arabic numerals. So the Islamic world is not just taking stuff from the Eastern Roman Empire. They're taking stuff from as far as the Islamic world. Like, for example, this really clever system of numerals. And, you know, again, if you've ever worked with Roman numerals, they're such a pain. They're so hard to work with. And here, I mean, in this list, please note you get the number 0. So 0 is a really powerful idea that comes from India that we'll talk about next week. It's sort of encoded into the system of numerals. The system of numerals gets transported into Europe from the Islamic world so it starts in the sort of Indian subcontinent, into the Islamic world, and into Europe. Okay. We haven't talked as much about philosophy as I think I want to, so let's do a little bit of it. I mean, those are all kind of practical, theoretical innovations. Perhaps one of the most important things that gets developed in this time is a new understanding of how science and philosophy and theology can relate to each other. So two really important groups in this time were Falsafa, which is just philosophy, and Kalam, which is sort of like Islamic theology. And these two groups, they're looking at the texts being imported into and translated into Arabic, and not all of it's compatible on its face with Islam. And that's of concern to them because Islam is really, really important to pretty much everybody who's doing this work. Islam and or Christianity or Judaism or Zoroastrianism. But for those of these people who were Islamic, their religion is crucially important to them, but nonetheless they want to continue to do study of the natural world and philosophy. So when these things are apparently not getting along, they need to figure out what to do. And it's in this space, I mean, I don't have time I can't do justice to this whole quite complex debate, but it's in this space where we start to see an independent zone being carved out for what will become science, independent of religion. So if you recall in our first lectures, I've been making the case that for the ancient world, typically science, religion, practical, technological stuff are all woven together into this undifferentiated whole. But here we start to see the separation become clearer, right? So as they carve out a space for philosophy, which is going to become science, independent from religion. So Bala mentions this person, Ibn Rushd, or Averroes, as particularly an important contributor here. So he argued essentially for the separation of religion and philosophy. And philosophy has as one of its sub-branches natural philosophy, which is the study of the natural world at this time. So in the Renaissance in Europe, what we see is essentially this idea popping up, hey, maybe we should be allowed to investigate the natural world in a way that's sort of autonomous from the religious picture. And you can see this being developed at great pains in the Islamic world prior to this idea popping up in Europe. So that's it's a philosophical or like a kind of contribution that's hard to quantify, but the kind of way, the skills and attitudes that are developed in trying to reconcile Islam with especially the Aristotelian philosophy get imported into Europe and I think Bala argues, helps to contribute to the attitude of humanism, which is characteristic of the Renaissance.